Welcome to Okonko Academy. So I would like to recommend that if you are new to this channel, you like and subscribe, and also you put us on post notification so that you always be notified on every new video uploaded. So in our previous tutorial, we talked about some applications of partial derivatives, that is on plane, tangent planes, and linear approximation. So in this tutorial, we are going to talk about directional derivatives and gradient. That's how to use partial derivatives to find directional derivatives and also the tangent of a given function. So in this tutorial, we are basically going to consider the first cases of directional derivative and gradient. So in the first case, we are going to consider a function of two dependent variables. So let's quick start with directional derivatives. So now with directional derivative, let's consider an example here. But first of all, the above equation is a general equation to find the directional derivative. So now this equation is defined as fx of xy cos theta plus fx of xy sin theta. So now our theta is the angle, and our angle will always be given. So now with our general equation, let's consider an example. So with the first example, we have a function f of xy, and our function is defined as x squared minus xy plus 3y squared. Now our theta was defined as the arc cos of 3 on 5. So now in mathematics, arc cos is the same as the cos inverse, and arc sine is the same as the sine inverse. Similar, the arc tan is the same as tan inverse. So now we've already defined that our theta is equal to the cos inverse of 3 on 5. That means that our cos theta is equal to 3 on 5. So now with this, we need to find our sin theta as well. So we can draw a simple right angle triangle. So now let's say our theta is here. Now with the cos, our cos from SOHCAHTOA is adjacent over hypotenuse. So now our adjacent is 3 and our hypotenuse is 5. So now our opposite, let's represent our opposite with x. Now going through our Pythagoras theorem, we know 5 squared is equal to x squared plus 3 squared. Now evaluating our x, you are going to end up getting our x to be 4. So now from SOHCAHTOA, we are going to get our sin theta to be equal to opposite, which is 4, over hypotenuse, which is 5. Okay, so now we have our cos theta and we have our sin theta as well. So with a general formula, we need our f, x, f, y. So now let's evaluate fx. So evaluating fx for our function. So our function, we have x squared. So now we get 2x. Now differentiating negative xy, we end up getting y. Now differentiating 3y squared, because the y is constant, we count 0. Now with our point, we have negative 1, 2. So we can evaluate 8 from here. So putting in our points, we have negative 1, 2, so minus 2. Now we have negative 2 minus 2 gives us negative 4. Now evaluating the partial differential with respect to y. From here, our x squared is constant, so it goes to 0. Now differentiating xy, end up getting x. And differentiating 3 y squared, we end up getting 6y. Now we have negative x. Our x is negative 1 plus 6y, and our y is 2. Now negative 1 times 1 gives us positive 1 plus 12. That gives us 13. Now we have our f x and our fy. Now let's put this in the general equation. So our directional derivative or the function is giving us our fx, which is negative 4, times our cos theta. Our cos theta is giving us 3 on 5 plus our fy 13 multiplying sin theta, which is giving us 4 on 5. Now expanding, we have negative 12 on 5. Now expanding this, we have 52 on 5. So now let's simplify. We are going to get 40 on 5, and 40 on 5 basically gives us 8. So therefore our question, that's we finding the directional derivative of our function on the point negative 1, 2 is giving us 8. As simple as that. So now let's move on to our gradient. That's how to find gradient when the function has two dependent variables. So now we have a general equation here, that's del f. Now this del means the gradient of this function. It's giving us fx I and fy j. So now remember, we are dealing with two variables, so therefore we are going to get x and y. In our next tutorial, we are going to go through the second cases, and that we are going to consider 3 variables. So now with the 3 variables, we are going to have x, y, z, and in that case our vectors are going to be I, J, and K. Now let's quick start with our first example. So in the equation up, we need our fx. Now differentiating this, our fx gives us 2x minus y. Now our 3y squared goes to 0. Now our fy gives us minus x plus 6y. So therefore our del f becomes 2x minus y I plus negative x plus 6y g. As simple as that. So now this gradient, we are not giving any point. So now let's assume a point, let's say at 0, 2. So now if it's at 0, 2, now we are going to substitute 0 in place of x and 2 in place of y. So now 2 times 0 gives us 0. Now negative y gives us negative 2i plus negative x. Our x is 0, so it goes away. Now 6 times 2 gives us 12, so plus 12g. As simple as that. Now our second equation, we are still going to use the same idea. So we have sine 3x cos 3y. So let's find the partial differential of f with respect to x. So now differentiating this, our cos 3y is going to be treated as constant because our y, we are not differentiating with respect to y, so y becomes constant. So we already have cos 3y being a constant. Now differentiating sine 3x, we end up getting 3 cos 3x. Okay. Now differentiate with respect to y. So now with y, similarly, our sine 3x will maintain, multiplying 3 by is negative, so negative sine 3y. So now similarly, our del f becomes, so now let's assume a point. So let's say at, let's say 0 pi on 2. So now with this, wherever we see x, we put 0, and wherever we see y, we are going to put pi on 2. And now pi on 2, we can evaluate in radian, but we can also convert to degree, and that becomes 90. So now here we have 3y. So now we are going to get cos 3 multiplying pi on 2 multiplying 3 cos 0, and that gives us 0 here. And now evaluating this, we have sine 3 times 90 multiplying negative 3 sine, sorry, it will be sine 3 times 0 because our x is 0 and our y is 90, so negative 3 sine 3 times 90, and that also gives us 0. So now you could see that because I used any point, that's why I'm getting 0. So now our derivative becomes 0. Is that okay? Now if I use a different point, I'm going to get another answer, but it all follows the same concept. So now, having understood the case 1 for directional derivatives and the case 1 for the gradient, we are also going to consider the case 2 in our next tutorial video. So please anticipate. Thank you.